After the Simulink is open, you will see this type of window, which you can see over here on the screen. Then click on Library Browser. When you click on Library Browser, you will see a window like this on the left side of the screen. Over here in the Simulink tab, you are going to see most commonly used block. So we are always going to use the blocks from Simulink. These are the advanced features which we are not going to use. So for example, you want to do something in control system toolbox, data acquisition, we will use them. But our case is simple. We are always going to use blocks from here. Now we will come back to the question. And the first part says that plot the transient response. So transfer function was already given to you. It was already provided to you in the class. And the transfer function was let's open it or transfer function okay, over here. So this is R over RCS plus 1, as you can see over here. Okay, so this is the transfer function. And this is the transfer function of the water tank. So the values of R and C are provided to you. So what we can do, we can come over here to the Simulink and we are going to make this transfer function. This is actually a closed loop feedback, which we are not going to do at this stage. So we have to only plot for open loop system. So it is R over RCS plus 1. So we'll come back to the Simulink and we will bring this, we'll come to continuous, and over here you will see an option for transfer function. Okay, so drag this block over here. So now this block is over here. So it's written transfer function over here on the bottom side. I can zoom it as well. Sure where to do it from. Simulation. Okay, anyway. So we double click on this. Okay, and over here we know that on the numerator side it's R. So I'm going to write down R over here. And over here we have R multiplied by C. And this is 1. So this is written in the vector form. So we have R and C are multiplied together, as we can see over here. So we do not write S because the first position is S to the power 0. The second position is S to the power 1. So over here on the first position, we have 1. And over here, the coefficient of S to the power 1 is R multiplied by C. So we can come over here again and we will write down the values of R and C. So create R, or you can do it on MATLAB as well. So there are two options. So this is the expression and model workspace, create it. Okay, we are not going to use the option from there. Rather, we are going to define the values of R and C over here on MATLAB. The value of R was, come to this side, we will see the value of R, which is 0.42. And remember that it has to be in SI units. So this is 0.42. And what is the value of C? C is not given, but diameter is given. So this is 14.25 centimeters. So 0.42 and 14.25 centimeters. So we have to convert it into meters as well. So we'll come back over here to MATLAB. So R is 0.42. Press enter. So you will see that this is going to come over here on the workspace. So R is defined as 0.42. C D is 14.25 divided by 100, and C is equal to pi divided by 4 multiplied by D multiplied by D. So pi by 4 D squared. So this is C. So now R and C are defined. And when we come back over here to the Simulink, you will see that they will become, they will become, the red is going to go away. So, okay. So it takes time to update on Simulink. So now you will see that there is no red. This means now the Simulink understand what is the value of R and C. So click OK, and you will see that this is going to update as well. If, for example, you make it small, then you will see numerator and denominator. If you zoom this box or make this box big, you will see R and RCS plus 1 explicitly shown. Now we are going to come over here to sources, and in the sources you will see step input. So over here you can see step input. So you can bring this block over here and left click. When you see a plus sign, then left click and move your mouse forward until you reaches to this greater than icon, and leave your left click mouse over there. So now this line is going to be connected. So this is source because this is giving you an input. So this block will be available in sources. Now in sinks, you will see the display, the scope, because it's an output. So you will see scope in the sync tab. So now again, when you will see a plus sign, then left click, move your mouse forward while keeping the left click button pressed. And then when you come to this greater than sign, then leave your left click mouse. So now this block is defined. Now the time has to be 0.05 seconds over here. The stop time, instead of 10, we are going to make 0.05. And then on the step input, the step time has to be 0. Initial time has to be 0, and the final time is 0.275 as given in the manual. So you come to the manual, you will see that this this step value is 0.275. Okay. So now this is defined, and step time is 0 because we want to start immediately. We want to start immediately up. So at time equals to t equals to 0, we want to have a step. If you want to have a step at time t equals to 1, then you are going to have some different value. And this initial value is of course going to be 0 because we are stepping from 0 to 0.275. But this number is always going to be 0. So click apply and then OK. And then we will run it. Okay. So when we run this, you will see that it's going to compile, and when you see 100% over there, then this means it's done. Okay. And then double click on scope, left double click on the scope, and you will get a graph. Okay. So this is the step input graph. If you want to show the step input along with the graph, you have to bring a mux block inside this Simulink. So we come over here to continuous, not continuous, commonly used blocks, and there is a mux block. Okay, so bring this mux block in, delete this line. Okay, and this is going to combine the two signals and show all the two signals on the same graph. So I can bring one line from here. So when you reach to this line, left click, sorry, not left click, right click. Okay, and then release the right click button when you reach to this greater than sign. Okay, then again, when you come to this class, left click and release your left click button when you reach to this greater than some. Similarly over here like this, and then run again. You have to run it again for the new simulation, and you will see both step input value as well as the the response of that step input. So the blue is actually response, and yellow is this step input value, which was 0.27. If you want to show the legend, you can come over here to view, and legend, click on legend, and it will automatically come over here. So this is transfer function, this is a step, so that you will know which one you want. And similarly, again, you can come to uh, view, and over here you can add axis and y axis over here. I'm not sure where that option is, but it's somewhere over here. If I get it quickly, I will show it to you. Time, name, simulation style, or simulation, axis scaling, measuring this goes. Axis scale, restore. Okay, anyway, so you can go to uh, Google and find out how to show x-axis as time and y-axis as uh, the height on Simulink scope. So you can always search it on the internet. Okay, the next question is uh, find the steady state liquid level H if the maximum allowed value of the liquid level H is H max is in the tank is 10 centimeter. Is this current level acceptable? So this is actually a theoretical part, so we are going to skip this one. Now the next one is after adding a proportional controller with the gain Kp equals to 0.5, use Simulink again to plot the transient response of the liquid level H in meter due to step reference input of magnitude 10 centimeter. So now we are going to come over here again to this Simulink block, select everything, left click and move, select everything, and then move this whole block diagram over here. Okay, but by clicking the left click mouse button. Then copy this. We are going to copy everything. You can do Control C, and then Control V, and then move this whole thing down. Now, what is the addition? Addition is the addition of P controller. So we will come over here to commonly used block. On this side, you will see gain. This is gain. Okay, so bring gain over here. And now we have to make a closed loop feedback. So this is your input, and we are going to make a closed loop feedback system. We have to also bring a summation block over here. So this is our summation block. Double click on this and make this one plus and minus. So this is plus and plus by default. So when you write plus and minus, so the center one will become plus and the bottom one will become minus. Click on apply and you will see that this sign changes to minus. Now we are going to delete this line, bring this plus in between, bring this plus over here, bring this gain in the middle. This is proportional controller. This gain is actually proportional controller. So we will bring this over here, and this is the feedback. So right click move your cursor to this point, right click, move your cursor to this point, and then join it to the minus side. Okay. Then right click and then join it to the plus side. So this is just a feedback. This is a feedback, closed loop feedback. So you have got the height value and the height value is fed back to this summation block. This is the reference input value. And this is the gain blocks. So this is called a closed loop feedback system. Okay. You can delete this one if you want, or you can keep that. This is just giving us the reference input value. So control Z, if you do control Z, you are going to come back to the previous stage. Now, what is the value of KP? KP is 5. So we'll come back over here and enter 5. And what it says, time is again 0.05. And what is the step H reference? Step input value, it's 10 centimeter, which means 0.1 meter. So we'll come back over here and we'll enter 0.1. So instead of having 0.275 now, this time it's 0.1 meters. MATLAB never take care of units, so you have to take care of units. Click apply, and then we are going to run. When we run both of them, both of the block diagrams will run. So it's going to run both the block diagram. Anything which is inside the window will run. So we will run it. So the time is already 0.05. So we will get this response. So we wanted the height of the liquid to be 0.1 meter, but the height has reached to 0. Almost 0.067 meters. So if I click over here, I'm not sure I can see the height or not. Anyway, so the difference between this reference value and the steady state value. So this is all steady state value, which is almost around 0.067. So the difference between the step input reference value and the steady state value is called the steady state error. So if I ask you this question in exam, what is the steady state error? So you can find it out from here. Okay, so the next is how much is the steady state error? So you can find the difference very easily. And even if, for example, you want to plot the steady state error, that can also be plotted from here. So this is the steady state error over here. Okay, so what is the next? Investigate the effect of changing the value of gain KP on the steady state error. So now we will work on 3 different values of KP. The first value is 3, second is 5, and the third one is 18. Okay, so we are going to copy this block diagram again. Copy this, Control C, Control V. Okay, and now we need to copy only this portion. We need to copy only this portion. Okay, so Control C and then Control V and 2 times Control V. So we are going to have one block over here and one block over here. Okay. The input is same for all the blocks. So the step input value is the same. Okay. So this is the step input value, which is same for everyone. And now the output, instead of having a mux with 2 inputs, we want how many? 4. So number 4. So what we do, we double click on this, double left click on this, and you will enter 4 over there. Okay, so now what we are going to do over here, we will just add it. Okay, so move this one forward. Now run this again. This is again 0.1. Then we haven't changed it. So this is again 0.1. Let me disable this one. this actually. So this is 0.1. I'm not changing. I want to disable this Grammarly. Maybe later disable this. Okay, so this is 0.1. And now over here, the values of R and C are same. We are not going to change them. They are same, but the gain value is going to be 3 for the first case, 5 for the second case, and 8 for the third case. Okay, so click apply, okay, and then run the simulation. So you will see, when you double click, you will see that this is actually the response. So the first one is transfer function 2, transfer function 4, or you can double click on this and delete this and write k equals to 3 for the first case. For the second case, it's k equals to 5. And for the third case, it's k equals to 8. Okay. So now click on this and you should see everything. Okay. Okay, so you have to actually, I disabled it. So when you click on this, it's gonna disable. So when you click on this one, it's gonna disable. If you click on this one, it's gonna disable. So I disabled it. So now you can enable it. So this is 3, this is 5, and this one is 8. Okay. So this is actually the this is actually related to the P controller. Now we are coming to the PI controller. So how to make a PI controller. So this is the first task. So what it says, the value of KPA and KI should be equal to 5. Now for PI controller, you have to add integral block. In addition to this proportional block, you have to add integral, and you have to sum them up. So we are going to add another gain and integrator, which means integration in S domain. And this is the block. So we are adding the summation, the proportional and the integral responses. So over here, we are going to have error. So error is multiplied with proportional gain, and then it is again at the same time multiplied with integral gain. And both values are added together and provided to the block diagram. So we are going to copy the same block diagram. So you can make this one small or arrange it. So we can arrange it over here. So bring it down, or you can leave it on this side as well and make it small. Okay, so select everything, then left click and move. Now what we'll do, we are going to add an integral controller. So we select this block, copy it, select this block, Control C, and then Control V. So bring this over here. Now we have to add an integral block. So what we do, move this one here. We should always arrange it nicely to avoid confusion. Move this one to this side. Okay. Now I can use my mouse wheel to zoom a portion. So I want to only zoom this portion, so I can use my mouse wheel to zoom. Okay, so zoom in and out. So over here, I want to add an integral block. So for adding integral block, we need a summation block. Now, one way is to come to this Simulink library, go to continuous, and then you go to commonly used block and drag this summation block. This is one way. Another way is left double click and write sum. If you remember what is the name of the block, you can just You can just search it from here by double left clicking. So if you think that this is the block which you were looking for, so click on this and this block will appear over here. Delete this line, move this block here, join the two lines, and then double click and write down integrator. Integrator. It's available in Simulink continuous. So it tells you also that where the block is located. So this is integrator. Double click, gain. So this is the gain block. Double click and gain. Now this gain block is available also in HDL coder. So in HDL it's available as well. And it's also available in Simulink. So if a block is available at two different places, it's gonna tell you. So click over here. Now what we do, we right click and drag a line. Okay. And then the values of KP, this is KP and this is KI, they both have to be 5. Click apply. This has to be plus plus, this has to be minus plus and minus. If you make this plus plus, then the graph is going to be different. So what is the step input value? So we'll come to this and same step input value, which is 0.27, 0.1. So KP and KI are going to be 1. So this is 0.1. It's written over there. And we come over here. So it's already 0.1. This is 5 and 5. Everything is fine. And what is the time duration? Time duration is, okay. This is actually, the theoretical part, which we are not going to do. This is the Simulink part. So KP, KI is 5. Reference input is 0.1 meter and time is 10 seconds. So we'll come back over here and write down there. So stop time is 10, run this one. And then you will see the plot. Okay, so you see that the steady state error, when you added the integral block, the steady state error became 0. So you can still double click and write down over here, PI controller KP equals to KI equals to 5. Okay. So click on this one so that the graph is available. So you see that if I add an integral controller, the steady state error becomes equal to 0. Okay. So that's it. This is what we did in the previous class. And now I'm going to stop the recording. Okay, so this is the first one is you can use your mouse wheel and zoom in and zoom out as well. And even you can drag. You can drag, use the pen and move the wheel. Now this feature is new. This was not there before. So you can drag as well. Okay, so this is done and I'm going to stop the recording now.